food label of your hamburger and seen how many calories your burger contains? Ever wondered how they know this? The technique used is calorimetry. This is the science of measuring heat transfer when a substance absorbs or gives out heat. A calorimeter is a device that we use to experimentally determine the heat associated with a chemical reaction. We will discuss two types of calorimeters later in the lesson. Before we start to measure heat transfer, let me introduce you to two common units of heat or energy you will come across. Firstly, the calorie. This is defined as the amount of energy or heat required to raise the temperature of 1 gram of water by 1 Celsius degree. The calorie is an old unit but is still commonly used today. The calorie used to describe the amount of energy in food is actually a kilocalorie, which is 1,000 calories. So our 500 calorie burger is really a 500,000 calorie burger. The SI unit for heat is called the joule and is defined in terms of the calorie. 1 calorie is equal to 4.184 joules. So now our burger is equal to 500 kilocalories, 500,000 calories, and over 2 million joules. It is important that you can easily convert between calories and joules. So let us do an example now. Express 28.4 joules of heat or energy in units of calories. Our conversion factor is 1 calorie is equal to 4.184 joules. So 28.4 joules multiplied by 1 calorie divided by 4.184 joules is equal to 6.79 calories. Notice we have set up the calculation so we can cancel the unit to leave us with calories. And don't forget to check for significant figures. In your everyday lives, you probably know that different substances respond differently when heated. It is important to know how materials respond to heat. You also need to think about how much of the material you have. How does the amount of the substance affect the energy required to heat it? Well, I'm sure you can see that heating up a large hamburger takes longer than heating up a small one. The amount of heat energy needed to change the temperature of a substance depends on three things. Firstly, the amount of the substance you are heating, which is the number of grams. The larger hamburger takes longer to increase in temperature compared to the small one. Secondly, the amount of temperature change, the number of degrees. The higher you want the temperature to go, the longer you need to heat it. And finally, the identity of the substance. Now we have already observed that different substances react differently when heated. It is also true that some substances require relatively large amounts of energy to change their temperatures, while others require relatively little. We call these differences heat capacity. Specific heat capacity is the amount of energy required to change the temperature of 1 gram of a substance by 1 Celsius degree. Here we can see a table of specific heat capacities of common substances. The higher the number, the more energy is needed to change the temperature of the substance. Notice that water has a very high specific heat capacity compared to the other substances. This is hugely important and is the reason why lakes and oceans are relatively slow to respond to heating or cooling compared to the land around it. Now we have the three factors that affect how much heat is needed to change the temperature. We can represent this by the following equation. Q is equal to S multiplied by M multiplied by change in temperature, where Q is equal to heat or energy, S is specific heat capacity, M is mass in grams, and delta T is the change in temperature in degrees Celsius. In the next section, we will use this equation to do some heat calculations. Let us return to the way we measure heat transfer using calorimetry. There are many different types of calorimeters, but I am only going to talk about the two you are most likely to come across. The first one is called the bomb calorimeter. Here, a chemical reaction is performed inside of a metal container that is immersed in water. All of the energy released by the reaction goes into heating the water. Our newly learned heat equation is used to figure out the heat of reaction. We know the specific heat capacity of the water, we know how much water we have, and we can measure the change in temperature. This is exactly the way nutritionists work out the energy content of food. The food is burned in the chamber and the temperature of the water is measured. The higher the temperature rises, the more heat is given out and the more calories the food contains. The other type of calorimeter you may encounter in the school or college lab is the coffee cup calorimeter. The setup is much simpler with just an insulated styrofoam cup, stirrer and a thermometer. The chemical reaction takes place in the coffee cup and the same calculations can be made. So let us finish with a couple of simple heat calculations. Question 1. How much energy does it take to heat 120 grams of water from 20 to 45 degrees Celsius? Here we can simply use our equation and put in the numbers. So Q is equal to Sm delta T, where S is 4.184 joules per degree Celsius per gram, multiplied by 120 grams, multiplied the change in temperature, which is 25 degrees Celsius. And if you calculate this out, it comes out to 13,000 joules or 13 kilojoules. Question 2. You have a 1.6 gram metal nugget, and it requires 5.8 joules of heat to change its temperature from 23 to 41 degrees Celsius. Is it pure gold? This is a little trickier, but we know that materials have specific heat capacity. We can use this as an identification tool. We can simply rearrange our equation above to calculate the specific heat capacity and put in the information we are given. Once we have this, we can compare it to the known specific heat capacity and see if it really is gold. So rearranging the equation S is equal to Q divided by mass multiplied by the change in temperature. And if we put in the numbers that we have, the answer comes out to S is equal to 0.20 joules per gram per degree Celsius. So looking back at the table, we see that the specific heat of gold is actually 0.13, and so this nugget is not pure gold. In this lesson you have learned that calorimetry is the science of measuring heat transfer when a substance absorbs or gives out heat. A calorimeter is a device used to experimentally determine the heat associated with a chemical reaction. We have learned two units of heat. The calorie is defined as the amount of heat required to raise the temperature of 1 gram of water by 1 Celsius degree. The joule is defined in terms of the calorie. 1 calorie is equal to 4.184 joules. We learned that substances have a specific heat capacity, which is the amount of energy required to change the temperature of 1 gram of a substance by 1 Celsius degree. And the simple equation Q is equal to Sm delta T can be used to work out heat calculations.